my dear students. Good morning to everyone. In previous video, we already discussed about structural isomerism. In that, structural isomerism, chain isomerism, position isomerism, functional metamerism as well as tautomerism with the examples. In this video, I am going to explain another type of isomerism, that is stereoisomerism. So here concept is about stereoisomerism. Stereoisomerism. What is stereoisomerism? Students, remember, here the compounds having same molecular formula as well as same structural formula. Remember, in presence of stereoisomerism, compounds having same molecular formula and same structural formula, but there is a special arrangement of atoms. There is a special arrangement of atoms observed in presence of structures. What is the special arrangement? Two types of isomerism in presence of stereoisomerism. Explain which type of arrangement appears in a particular compound. In this stereoisomerism, there are two types. One is geometrical isomerism and another one optical isomerism. Before going to the geometrical isomerism, first we remember the concept what is stereoisomerism. The isomerism in which the compounds having same molecular formula and same structural formula, but only there is a special arrangement of atoms are involved. Yes, now take another heading. In presence of stereoisomerism, first one is geometrical isomerism. Geometrical isomerism. Geometrical isomerism. Yes, what is geometrical isomerism? Remember, I write here definition. The compounds having same molecular formula and structural formula. Same molecular formula and structural formula, but differ in the special arrangement of atoms. Special arrangement of atoms around the double bond. Yes, so you remember this point because this is very important. What is this? Geometrical isomerism. It says the compounds having same molecular formula and structural formula but differ in the special arrangement of atoms around the double bond. This one is very important. In presence of geometrical isomerism, there is a special arrangement of atoms around the double bond is appeared. Double bond means the compounds are alkenes. Is it right? Yes. In alkenes, the geometrical isomerism is observed. Example. ಇದನ್ನು ತಗೊಂಡಿದ್ಯಾ ಇಲ್ಲಿ ಈ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಅಂದ್ರೆ ಸಾವಯವ ಸಂಯುಕ್ತಗಳು ಅಂತ ಏನ್ ಕರಿತೀರಿ ಅಥವಾ ಐಸೋಮರ್ಸ್ ಅಂತ ಏನ್ ಕಲ್ತಿದ್ದೀರಲ್ಲ, ಆ ಐಸೋಮರ್ಸ್ ಗಳನ್ನ ನೋಡಿದಾಗ ಅಲ್ಲಿ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಸೇಮ್ ಕಂಡು ಬರ್ತಿರ್ತದೆ, ಅದೇ ತರ ಸ್ಟ್ರಕ್ಚರಲ್ ಫಾರ್ಮುಲಾನು ಕೂಡ ಸೇಮ್ ಕಂಡು ಬರ್ತಿರ್ತೈತಿ. ಆದ್ರೆ ಆ ಒಂದು ಡಬಲ್ ಬಾಂಡ್ ಸುತ್ತ ಏನು ಆಟಮ್ಸ್ ಇರ್ತಾವಲ್ಲ ಅವುಗಳದ್ದು ಜೋಡಣೆ ಏನಾಗಿರ್ತದೆ ಡಿಫ್ರೆಂಟ್ ಆಗಿ ಕಂಡು ಬರ್ತಾ ಇರ್ತದೆ. ಅಂತಲ್ಲಿ ನಾವು ಜೊಮೆಟ್ರಿಕಲ್ ಐಸೋಮೆರಿಸಮ್ ಅನ್ನೋದನ್ನ ಕಾಣ್ತೇವೆ. Yes, example 1. I take general example. Here I write two carbon atoms with double bond, and here generally I take A and A here and B and B here. ಇಲ್ಲಿ ನೋಡಿ ಈ A ಅಂತಕ್ಕಂಥದ್ದು ಇಲ್ಲಿ A ಅಂತಕ್ಕಂಥದ್ದು ಈ ಒಂದು ಕಾರ್ಬನ್ ಆಟಮ್ ಡಬಲ್ ಬಾಂಡ್ ಇನ್ವಾಲ್ವ್ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ಗೆ ಒಂದೇ ಸೈಡಿನಲ್ಲಿ A ಅಂತಕ್ಕಂಥದ್ದು ಸಿಮಿಲರ್ ಗ್ರೂಪ್ಸ್ ಅದ, ಹೌದಾ? ಇಲ್ಲಿ ಬಿ ಟಿ ಅಂತಕ್ಕಂಥದ್ದು ಸಿಮಿಲರ್ ಗ್ರೂಪ್ಸ್ ಅದ. ಈ ಸ್ಟ್ರಕ್ಚರ್ಗೆ ನಾವು ಸಿಸ್ ಅಂತ ಕರೀತೇವೆ. ಸಿಸ್ ಮೀನ್ಸ್ ಸೇಮ್ ಸೈಡ್. ಏನಪ್ಪ ಸಿಸ್ ಮೀನ್ಸ್ ಸೇಮ್ ಸೈಡ್. And another structure, it also involves two carbon atoms which contain double bond, but now I write A here and another A here, and one B is here and another one B is here. Yes, what is the difference between these two structures? Remember students, if the similar groups are present on same side of the double bond, then it is called cis isomer. If the similar groups present on opposite direction or opposite to each other, then it is called by the name trans. It is the trans isomer and this one is the cis isomer. ಯಾವಾಗ ಸಿಸ್ ಆಗಬೇಕು ಯಾವಾಗ ಟ್ರಾನ್ಸ್ ಆಗಬೇಕು ಅನ್ನೋದನ್ನ ನೀವು ತಿಳ್ಕೋಬೇಕು. If two similar groups are present on same side of the double bond, then it is cis. If they are arranged in opposite direction, then it is trans. Yes. Take another example. Very important. This one is very important. Example number 2. Or this question. One question is asked on this concept. The question is like, write the cis and trans form of bute 2-ene. Very important. First I write here name of the compound, bute 2-ene. Bute 2-ene. Remember students, geometrical isomerism, it appears in presence of cis form and trans form compounds. What is cis? Similar groups are present on same side of the double. What is trans? Similar groups present in opposite direction. Yes, first you write the structure of bute 2-ene. Here I write written only the name. Bute 2-ene ಅಂತ ಏನು ಬರೆದಿದೆ ನಾನಲ್ಲಿ ಕೇವಲ ಹೆಸರನ್ನ ಬರೆದಿದೆ. First you write the structure. Here I write the structure. Bute means it contains 4 carbon atoms. 3, 4. Is it right? Yes. Next, what this 2 indicates? Second carbon atom contains ene. Ene means it contains double bond, and you also know double bond containing compound shows geometrical isomerism. As if you start from this side 1, 2, 3, 4, second carbon atom contains double bond. Bute 2-ene ಅಂತ ಹೆಸರು ಬರ್ತೀವಿ. ಎರಡನೇ ಕಾರ್ಬನ್ ಆಟಮ್ ಏನು ಬರ್ತಾನೆ ನಾನು ಇಲ್ಲಿ ಡಬಲ್ ಬಾಂಡ್ ಬರ್ತಾನೆ. ಉಳಿದಿದ್ದು ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡೋದು. ಹೇಗೆ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡ್ತೀವಿ? ಸಿಂಗಲ್ ಬಾಂಡ್ ಅದ ಅಂತ ಉಳಿದಿದ್ದು CH3. ಇಲ್ಲಿ 1, 2, 3 ಬಾಂಡ್ ಅದ ಅಂತ ಉಳಿದಿದ್ದು ಓನ್ಲಿ H. Here also only H. Here CH3. Yes, this is the structure of bute 2-ene. ಮತ್ತೆ ಸ್ಟ್ರಕ್ಚರ್ ಅನ್ನ ಬರೀಬೇಕು. ಆಮೇಲೆ ಇದರಿಂದ ಸಿಸ್ ಫಾರ್ಮ್ ಮತ್ತು ಟ್ರಾನ್ಸ್ ಫಾರ್ಮ್ ಅನ್ನ ಬರೆಯಬೇಕು. Okay, I already told you, cis form means two similar groups or alkyl groups present on same side of the double bond. Yes, here while writing the cis and trans form, first you select the carbon atoms which contain double bond. ಈ ಸಿಸ್ ಮತ್ತು ಟ್ರಾನ್ಸ್ ಫಾರ್ಮ್ ಬರೀಬೇಕಾದ್ರೆ ನಾನು ಮೊದಲು ಏನನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು ಅಥವಾ ಏನನ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು ಅಂದ್ರೆ ಈ ಒಂದು ಸ್ಟ್ರಕ್ಚರ್ ಅಲ್ಲಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಏನದಾವಲ್ಲ ಅದು ಡಬಲ್ ಬಾಂಡ್ ಯಾವ ಜೊತೆ ಅದ ನೋಡ್ರಿ, ಆ ಕಾರ್ಬನ್ ಆಟಮ್ ಅನ್ನು ನಾವು ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. Yes, observe here this carbon atom and this carbon atom contain double bond. Therefore, I select those carbon atoms and written here. Yes, C double bond C. Okay, ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಅನ್ನ ಇಲ್ಲಿ ಬರೆದೇನೆ, ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಅನ್ನ ಇಲ್ಲಿ ಬರೆದೇನೆ. ಈಗ ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಇಲ್ಲಿ ಇರೋದಲ್ವಾ, ಇದ್ರ ಜೊತೆ ಏನದ ಒಂದು H, ಆ H ಅನ್ನ ನಾನು ಇಲ್ಲಿ ಬರೆದಿದ್ದೇನೆ. Is it right? Yes. ಇನ್ನೊಂದು ಏನದ ಒಂದು H ಅನ್ನ ಇಲ್ಲಿ ಬರೆದಿರಿ, ಉಳಿದಿದ್ದ CH3 ಗ್ರೂಪ್, ಆ CH3 ಗ್ರೂಪ್ ಅನ್ನ ಇಲ್ಲಿ ಬರೆದಿದ್ದೇನೆ. ಸಿಮಿಲರ್ಲಿ ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಇಲ್ಲ, ಇದ್ರ ಜೊತೆ ಏನದ ಒಂದು H, ಈ H ಅನ್ನ ಇಲ್ಲಿ ಬರೆದಿದ್ದೇನೆ. ಇದು ಉಳಿದಿದ್ದ ಇನ್ನೊಂದು CH3. Yes. Observe carefully. According to the concept, if two similar groups are present on same side of the double bond, then it is cis form. Cis form. This is the cis form of but2ene. And similarly, take these carbon atoms which are involved in double bond carefully, and here I change the atoms arrangement. I write these two similarly. This one H and this one CH3 I write similarly, but now it is changed. I write this CH3 in above. I write this CH3 here and this hydrogen is here. As what is the difference between these two structures? Here similar groups present on same side of the double bond, but here two similar groups present on opposite in direction. Therefore, it is transform. This is the transform of but2ene. Is it right? Select ಮಾಡ್ಕೊಳ್ಳೋದು important. ಹೇಗೆ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ತೀರಾ? ಮೊದಲು ನಾವು ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕ್ರಿ, ಸಿಸ್ ಮತ್ತು ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಬರೀಬೇಕಾದ್ರೆ ಎರಡು ಕಾರ್ಬನ್ ಆಟಮ್ ಯಾವ ಡಬಲ್ ಬಾಂಡ್ ಹೊಂದಿರ್ತಾವಲ್ಲ ಅವನು ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. ಈಗ ನೋಡಿ, ಇಲ್ಲಿ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡೆ ಈಗ ಕಾರ್ಬನ್ ಆಟಮ್. ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಏನು ಬರ್ತೀನಿ, ಇದ್ರ ಜೊತೆ ಒಂದು H ಅದ, ಅದನ್ನು ಸಪರೇಟ್ ಆಗಿ ಬರ್ತೀನಿ. ಉಳಿದಿದ್ದು CH3 ಗ್ರೂಪ್ ಇಲ್ಲ. ಇಲ್ಲಿ ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಈ ಒಂದು H ಇಲ್ಲಿ ಬರ್ತಾರೆ, ಈ CH3 ಇಲ್ಲಿ ಬರ್ತಾರೆ. ಈಗ ನೆಕ್ಸ್ಟ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಬರೀಬೇಕಾದ್ರೆ ಇವು ಎರಡೂ ಸೇಮ್ ಹೋಗ್ತಾನೆ, ಬಟ್ ಇದನ್ನು ಮಾತ್ರ ಏನು ಮಾಡ್ತಾನೆ, ರಿವರ್ಸ್ ಮಾಡ್ತಾನೆ. ಅವಾಗ ಅದು ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಆಗ್ತದೆ. Very important for 2 marks question. Question appears like this: write the cis and transform of but2ene. It is very important. Okay, now you try. Next one. Second example. Pent2ene. Okay. You only solve. Write the cis and transform of pent2ene. Yes, this is pent2ene. Pent means there are 5 carbon atoms. Is it right? Next, second one contain ene means there is a double bond present on the second carbon atom. Here CH3, here only H, I write H only. Here also only H, here H2, here CH3. Is it right? Yes. Now, how you write cis and transform? Just as of this, because I will change the atoms here. You write separately and identify the cis and transform. Yes, first you select these 2 carbon atoms. Why I select these 2 carbon atoms? Because according to the concept, the carbon atoms which are involved in the double bond are taken first. Yes, ನಾನೀಗ ಈ ಒಂದು ಕಾರ್ಬನ್ ಆಟಮ್ ಅನ್ನ ಇಲ್ಲಿ ಬರ್ಕೊಂಡೇನೆ. ಈಗ ನೋಡಿ, ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಇಲ್ಲದ ಇದು, ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಜೊತೆಗೆ ಏನದ ಇದೆ H, ಆ H ಅನ್ನ ಇಲ್ಲಿ ಬರೀತೇನೆ. ಇನ್ನೊಂದು ಏನದ ಇದೆ CH3 ಅನ್ನೋದರ. ಅದೇ ತರ ಈ ಕಡೆ ಬರುತ್ತೆ, ಇಲ್ಲೇ ಈ ಕಾರ್ಬನ್ ಜೊತೆ ಏನದು H ಇಲ್ಲಿ ಬರೀತೇನೆ. ಈಗ ನೋಡಿ, ಇದು CH2 CH3. You write either CH2 CH3 or simply C2H5. Is it right? Yes. Students, observe carefully. Here 2 alkyl groups present on same side of the double bond, then it is cis form. Similarly, first I write these groups as usual HCS3, but this group is changed here. Here I write C2H5, here H. Yes. Here alkyl groups are you observe hydrogen. Similar groups present on opposite direction, therefore it is transformed. Okay, you take different examples and write the IUPAC name. Yes, this is about the geometrical isomerism. In presence of stereoisomerism, the first one is geometrical isomerism. Okay, students, next another type of isomerism, that is optical isomerism. Optical isomerism. The detailed study of this geometrical isomerism and optical isomerism also appears in your another chapter, that is hydrocarbons. ಈ ಹೈಡ್ರೋಕಾರ್ಬನ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಕೂಡ ಇದು ಬರ್ತದ, ಅಲ್ಲಿ ಮತ್ತೆ ಇದರ ಬಗ್ಗೆ ನಾವು ಹೆಚ್ಚಿಗೆ ಕಲಿಯೋಣ. ಈಗ ಜಸ್ಟ್ ಡೆಫಿನಿಷನ್ and example. Yes, what is optical isomerism? Students, first you know the definition of this optical isomerism. I write here: the compounds having same molecular formula. The compounds having same molecular formula and structural formula. But change in the placement of atoms. Change in the placement of atoms due to plain polarized light. Yes, this is the definition. The compounds having same molecular formula and structural formula, but change in the placement of atoms due to plain polarized light. Students, remember, in presence of mirror, the place of the atoms appears as different. It indicates the special arrangement of atoms. In presence of optical isomerism, the placement of atoms is appear differently due to the plane polarized light. Take one example, it clears to you. Example. ನೆನಪಿಡಿ, ಈ ಒಂದು ಕಾಂಪೌಂಡ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಅನ್ನ ನೋಡಿದಾಗ ಅವರದ್ದು ಸೂತ್ರ ಅಂದ್ರೆ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಏನಾಗಿರ್ತದೆ, ಸೇಮ್ ಆಗಿರ್ತದೆ. ಬಟ್ ಆ ಆಟಮ್ಸ್ ಸ್ಥಾನ ಏನಾಗ್ತದ, ಬೇರೆ ಬೇರೆಯಾಗಿ ಕಂಡು ಬರ್ತದೆ. ಈ ಸಪೋಸ್ ಒಂದು ಮಿರರ್ ನಾವು ಹೋಗಿ ಈಗ ಮಿರರ್ ನೋಡಿ ನಿಂತೆಪ್ಪ, ನಾನೇ ಕಾಣ್ತೇನಲ್ವಾ ಅದರಲ್ಲಿ, ನೀವು ನಿಂತ್ರೆ ನೀವೇ ಕಾಣ್ತೀರ, ಹೌದು. ಎಸ್, ಬಟ್ ಈಗ ಒಂದು ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ದ ಕಂಪೌಂಡ್ ಅನ್ನು ಮಿರರ್ ಮುಂದೆ ನಾವು ಇಟ್ಟಾಗ ಏನಾಗ್ತದೆ, ಅವಕ್ಕೂ ಪೊಸಿಷನ್ ಅಂದ್ರೆ ಪ್ಲೇಸ್ ಆಫ್ ದ ಆಟಮ್ಸ್ ಡಿಫ್ರೆಂಟ್ ಆಗಿ ಕಾಣ್ತದೆ. ಹೇಗೆ ನೋಡೋಣ. Here I take an example, that is lactic acid. Yes, lactic acid. Structure of lactic acid is like this. And write here OH, and here I write H, here CS3. Yes. When you place the mirror here, yes, if you place the mirror here, then this compound structure appears like this. Yes. What is the difference between these two? Here OH group is present on right side, here OH group is present on left side. Means there is a special arrangement of atoms is observed due to the mirror. Students, remember, this is about the optical isomerism. The name of the compound, I told you this is lactic acid. Is it right? Yes, this is also lactic acid. But instead of writing lactic acid only, I write this one as D-lactic acid and this one as L-lactic acid. What this D indicates, what this L indicates, that is very important. Remember students, this D indicates dextro. D andre ಏನಂತ dextro. Dextro andre right side. Here, okay, ನಿಮಗೆ ನಂಬರಿಂಗ್ ಸಿಸ್ಟಮ್ ಗೊತ್ತದ. ಹೈಯರ್ ಪ್ರಿಯಾರಿಟಿ ಇರತಕ್ಕಂಥದ್ದನ್ನ ಒಂದು ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು ಲೋವರ್ ಪ್ರಿಯಾರಿಟಿ ಇರತಕ್ಕಂಥ ಕಡೆ ಹೋಗಬೇಕು ಅಂತೇಳಿ. Yes, between these two, COH group and OH group, which one has higher priority? COH group. ಈ ಎರಡರೊಳಗೆ ಯಾವುದು ಜಾಸ್ತಿ ಪ್ರಾಧಾನ್ಯತೆ ಕೊಡ್ತೀರಿ ನೀವು? COH group ಅಲ್ವಾ? ಓಕೆ, ಹಾಗಾದ್ರೆ ಈಗ ಈ ಕಡೆಯಿಂದ ಈ ಕಡೆ ಹೋಗ್ತೀರಾ. Yes, this is clockwise direction or anti-clockwise direction? Clockwise direction. Okay, clockwise direction ನಲ್ಲಿ ಇದು ಕಂಡು ಬರಕತ್ತಿತ್ತು ಅಂದ್ರೆ ಅದಕ್ಕೆ ನಾನು D ಯೂಸ್ ಮಾಡ್ತೇನೆ. ಯೂಶುವಲಿ D ಅಂದ್ರೆ ಏನು? Dextro ಅಂದ್ರೆ meaning right side ಅಂತ ಹೇಳಿ. Here is COH group and here. Therefore, it is in anti-clockwise direction. Therefore, I write this one as L. This L indicates levo. Levo. Is it? Levo means left side. Okay. You observe this OH group and this one OH group. The placement of atoms is different here. Where? In presence of optical isomerism. Is it right? Yes. Remember the definition and one example for geometrical isomerism as well as optical isomerism. Okay, students. Next, I move to the another one concept. It is about some rotations. What are those rotations? ಏನು rotations ಅಂದ್ರೆ ಯೂಶುವಲಿ ಸಾಂಕೇತಿಕಗಳು ಅಂದ್ರೆ ಕೆಲವೊಂದಿಷ್ಟು ನಮಗೆ ಇಂಪಾರ್ಟೆಂಟ್ ಬೇಸ್ ಪಾಯಿಂಟ್ಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಇದ್ರ ಬಗ್ಗೆ ನಮಗೆ ಐಡಿಯಾ ಇರಲಿ. What are those? See here. One is, students, you know about carbon and carbon containing compounds now. And in presence of carbon containing compounds, some compounds contain primary carbon atom, some compounds contain secondary carbon atom, some are tertiary carbon atom. Therefore, first we see what is primary carbon atom, what is secondary carbon atom, and what is tertiary carbon atom. First, I take primary carbon atom. And it is also written like this. Primary carbon atom. Primary carbon atom ಅಂದ್ರೆ ಏನು? Students, remember, if one of the carbon atom it is attached with only other one carbon atom, then it is said to be a primary carbon atom. Primary carbon atom ಅಂತ ಹೇಳಬೇಕಂದ್ರೆ ನೀವು ಒಂದು ಕಂಪೌಂಡ್ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಪ್ಪ. ಅದರೊಳಗೆ ಏನಾಗಬೇಕು? ಒಂದು ಕಾರ್ಬನ್ ಆಟಮ್ ಮತ್ತೊಂದು ಕಾರ್ಬನ್ ಆಟಮ್ ಜೊತೆ ಮಾತ್ರ ಬಂಧವನ್ನ ಏರ್ಪಡಿಸಿಕೊಂಡಿರಬೇಕು. ಸಿ ಐ ಟೇಕ್ ದಿಸ್ ಎಕ್ಸಾಂಪಲ್. No, empty means here it contains CH3 and here is CH3. Yes, when you consider this carbon atom, it is bonded or it is attached with only one carbon atom. Therefore, this is referred as primary carbon atom. ಹಾಗಾದ್ರೆ ನೀವು ಅಂತೀರಾ ಸರ್ ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಒಂದು ಒಳಗೊಂಡಿತ್ತು ಅದಕ್ಕೆ ಪ್ರೈಮರಿ ಅಂತ. మరి ಇಲ್ಲಿ ಇದು ಕೂಡ ಏನಾಗಿದೆ? ಒಂದಕ್ಕೆ ಒಳಗೊಂಡದ. therefore it is also a primary carbon atom. Remember students, if the carbon atom is attached with only one carbon atom, then it is said to be an primary carbon atom. Next, secondary carbon atom. ಇದನ್ನ ಅರ್ಥ ಆಗ್ತಿರ್ಬೋದು. ಒಂದು ಕಾರ್ಬನ್ ಆಟಮ್ ಮತ್ತು ಒಂದೇ ಕಾರ್ಬನ್ ಆಟಮ್ ಜೊತೆ ಇದ್ರೆ ಪ್ರೈಮರಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಒಂದು, ಸೆಕೆಂಡರಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂದ್ರೆ ಏನು? Remember students, if one of the carbon atom it is attached with other two carbon atoms, then referred as secondary carbon atom. ಏನಿದ್ರಂತ ನಾವು ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ಸ್ ನೋಡುತ್ತಿರುವಂತಹ ಸಂದರ್ಭದಲ್ಲಿ ಒಂದು ಯಾವುದೋ ಕಾರ್ಬನ್ ಆಟಮ್ ಬೇರೆ ಎರಡು ಕಾರ್ಬನ್ ಆಟಮ್ಗಳ ಜೊತೆ ಬಂಧವನ್ನ ಏರ್ಪಡಿಸಿಕೊಂಡಿದ್ರೆ ಅದಕ್ಕೆ ನಾನು ಸೆಕೆಂಡರಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂತ ಕರೀತೇನೆ. ಹೇಗಿರ್ತದೆ ಇದು? ಸಿ I write as I act like this. Here carbon chain is present. So let's see here. If you take this carbon atom, it is primary or secondary? Yes. This carbon atom is attached with here one carbon atom and here one carbon atom. Means totally it is attached with two carbon atoms. According to our point, secondary carbon atom means here the carbon atom is attached to two different carbon atoms. Is it right? Therefore, this one is considered as a secondary carbon atom. What about this? Idhan ಏನಂತ ಹೇಳ್ತೀರಾ? Here this carbon atom is only attached with this carbon atom. ಸಂಬಂಧದವರು ಅದು ಬೇಡ ನನಗೆ. ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಜೊತೆ ಬಂದ ಎಷ್ಟು ವರ್ಕ್ ಮಾಡಿದ್ದಾರೆ? ಒಂದು ಕಾರ್ಬನ್. only one carbon atom, therefore it is primary carbon atom. What about this? Here it contains one bond here with another carbon atom, one bond here with this carbon atom, therefore it is also secondary carbon atom. What about this? This is primary. Why this is primary carbon atom? Because it contains only one bond. Is it right? Yes. What is primary carbon atom? What is secondary carbon atom? It's clear to you, I think. Okay, next, another one type. Tertiary carbon atom. ಈಗ ನೀವು ಪ್ರೈಮರಿ ಗೊತ್ತದ ಸೆಕೆಂಡರಿ ಗೊತ್ತದ ಅಂದ್ರೆ ಈಸಿಯಾಗಿ ಟರ್ಷರಿ ಕೂಡ ಅರ್ಥ ಆಗಿರ್ತದ ಅಂತ ಹೇಳ್ತೀವಿ. ನೋಡು, ಟರ್ಷರಿ ಕಾರ್ಬನ್ ಆಟಮ್. If the carbon atom is attached with the other three carbon atoms, then it is referred as a tertiary carbon atom. See here, students. Here I write structure of tertiary carbon atom. Yes, among these, which one is the tertiary carbon atom, which one is secondary, and which one is primary? So let's first take this carbon atom. This is bonded with one bond, therefore, and it is attached with another a single carbon atom, therefore this is primary. What about this? Here this one carbon atom and this one carbon atom, therefore it is secondary. Then what about this? This is very important. Now here this is important because this carbon atom is attached with here one, here two, here another one, three. Therefore this is tertiary carbon atom. One of the carbon atom, if it is attached with three carbon atoms, then it is taken as a tertiary carbon atom. Clear ಇದು? ಒಂದು ಕಾರ್ಬನ್ ಒಂದೇ ಒಂದು ಕಾರ್ಬನ್ ಆಟಮ್ ಜೊತೆ ಹೊರಗೊಂಡಿದ್ದು ಬಂಧವನ್ನು ಏರ್ಪಡಿಸಿಕೊಂಡಿದ್ದು ಅಂದ್ರೆ ಅದು ಪ್ರೈಮರಿ ಕಾರ್ಬನ್ ಆಟಮ್. ಒಂದು ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಅವರ ಈ ಕಡೆ ಎರಡು ಕಾರ್ಬನ್ ಆಟಮ್ಗಳು ಇರಬೇಕು ಅಂದ್ರೆ ಅದು ಸೆಕೆಂಡರಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಅನ್ಸ್ಬೋದು. Tertiary ಅಂದ್ರೆ one of the carbon atom, it is attached with three other carbon atoms. This is tertiary carbon atom. Okay students, in this video only I explained about two types of isomerism. One is geometrical isomerism and another one optical isomerism. In that, geometrical isomerism is very important. Please remember that point because it helps to your future also. Next, in presence of locations, there are three types. One is primary, secondary, as well as tertiary carbon atoms. Okay, in next video, we will move to the other very important concept, that is homolysis, or also called as homolytic fission and heterolytic fission. Thank you.